Hi everyone, good day. I am Herminio and today I'll be presenting introduction to statistical analysis in research. And don't you know that research and statistics are like husband and wife? You cannot separate them. Once you do research, it is imperative that you will have to do statistics in any way. You will have to count because you will be dealing with data. Now, may I ask you a question? What will be the first thing you have to look at for a paper or for a thesis or for a dissertation or for a paper? Once you do research, are you looking at with the review of related literature, or are you looking at first with the statement of a problem or with the research title in research variable or research framework and so on and so on? You know, many of us have different types of what we look for a particular research. Once we evaluate, we critique a paper. Sometimes there is always a thing that we have to look at first. But personally, when I try to look at first the research variable. You know, research variable are concepts which are measurable that assumes more than one value. So you remember the word value in statistics. Value means something numerical, things that you will have to count, and it is expressed and collected as data. Thus, when research is dealing with data, so meaning to say you cannot really separate it from statistics unless you are not dealing with these things. So but research are all about things that you have to measure, things that expresses value, and it refers to data and all of these things. So thus, I as a researcher, I look at into first these things, the research variable, uh, and then the measurability of these things, or else if it is not, it just remain a concept. It is expressed and collected as data. You know, sometimes there are things that comes to our mind and it just remain a concept unless you try to measure it, and that becomes now a variable, a research variable. Sometimes we say, how about love? Can we quantify love? Yeah, you cannot quantify love, but if you try to express it in and if you assume something that this could express about love, like for example giving, the number of givings, the amount that you have to give, or the frequency of giving, and the quality or the quantity of what you give, that could be equated to loving. Then yeah, we can measure. But remember, always remember the things that it must be measured, and it can be measured, measurable, and you can collect it, and that becomes data. And when we talk about data, there are 4 levels of data measurements in statistics, starting with nominal, the ordinal, interval, and ratio. Very easy to remember. There are only 4 types of data, 4 levels of data measurement: nominal, ordinal, interval, and ratio. When we say nominal, it categorizes, it labels, it classifies, it names, or it identifies types of kinds of things that can be quantified. And just like name of people, the geographical location, color of the hair, and so on. Anything that just simply labels or classify things, the kind of tribes, all of these things are nominal type of data. And sometimes this is the easiest way to measure. And then secondly is ordinal. It provides rank order of objects or individuals from the first to the last, or from the best to the worst. So when you're dealing with which one is the smartest guy in the room, which one is the dullest, which one is having the highest score in the room and the lowest, All of these things are ordinal type of data. Which one is the prettiest? These are ordinal type of data. The third one, as we go along, it gets a little complicated. Interval data includes rank ordering and these additional characteristics, the equal intervals, or distance between adjacent numbers. And here zero has no absolute point. What does it mean? Example of these are, the measures of temperature. Like for example, 0 degrees Celsius. 0 degrees Celsius has meaning. The zero in temperature, the measures of temperature has meaning. Meaning to say that 0 degrees Celsius could be the freezing point of water, and this could have some meanings when you have to interpret it. So remember, interval data are data that could be that has equal intervals, and zero has no absolute point, and then zero has meaning, just like temperature. And the last one, which is the hardest, is it includes rank ordering in equal intervals and with additional characteristics. There is an absolute 0 point, so which permits forming ratio statements. Okay, so like height, weight. When you try to measure height, there's no such thing as zero height here. So once you indicate a zero height, it could mean that there's an absence of that variable, that there's no variable that could exist with a zero value. But that's the meaning. So here, zero really could mean non-existence. There could be no. It could mean non-existence of a particular variable. And this is the summary of all my presentation of how statistics work when you do research in relation to the levels of data measurements. So we categorizes this, you categorizes this data, this type of or levels of data measurement into two groups. The nominal and ordinal is categorized as descriptive, and interval and ratio categorizes as inferential. Remember, there are two camps of statistics: the descriptive statistics and the inferential statistics. So nominal and ordinal types of levels of data measurement falls into the descriptive statistics, while the interval and ratio type of levels of data measurement falls into the inferential statistics. So let's start with the descriptive statistics, trying to look at these 5 forms of measures. The first one is the measure of central tendency, and the measures of central tendency refers to the mood, median, and the mean. If you try to measure the central tendency, could mean that we have to measure the data. By the word itself, central, we have to look at the data, we have to measure the data, the values really at the center of the spread. So remember, the data has the particular range, the lowest and the highest range of the data. So let's say, for example, from 1 to 100, we try to look into what is really the central point of this entire data set. So for example, the mood is the most occurring data in the data set. It is like a I'll give you an example. No? The most values that occur in an entire data set. So for example, when you try to count all the values, those values that repeats most of the time, and with the highest frequency, that could be considered as the mood. So like for example, I will give you 1, 2, 3, 4, 5, 6, 7, 7, 7, 8, 9, 10. In that data set from 1 to 10, 1 is the lowest, 10 is the highest, 7 occur 3 times, and that becomes the mood. And the median, the median, there's an easy way to calculate the median, that you just have to subtract the highest value, the maximum value, the minimum value, max minus the mean, and then you have to divide it by 2 in a range of, let's say the highest is 100, the lowest is 1, then you will have 49.5. When you subtract 100 to 1, you get 99, and you divide it by 2, then it gives you 49.5, and that could be the median. The mean is, you have to add all of the values in the data set, and you have to divide it the number of the frequencies of those values, and that gives you the mean, or something we call it when the average. This is the summation of all values, plus then you have to divide it the number that it occurred in the particular data set. So the mood, median, and the mean tries to measure the data, the central point of the data in the entire data set. The next one is the measure of variability. This time you have, sometimes we call this one the measure of dispersion, where you have to measure what is really the data look like from the mean, from the point at the center. When at the measure of central tendency, we have to measure the data at the center. Here we try to measure the data from the mean. So that is the measure of variability. Sometimes we call this one the measure of dispersion. How dispersed is the data? And we have the range, variance, and the standard deviation. Range is we try to look into what is the mean and the max. And then the variance, and then the standard deviation. The variance simply helps you to calculate standard deviation, because you will have to square the variance, and then you get the standard deviation. So the standard deviation tells you something about how far a particular value from the mean, and it is expressed through a z-score. Like for an example, a z-score of 1 is around 68% of all data before and after the mean, and z-score number 2, and then z-score, and so on. And yeah, so if the bigger the standard deviation, meaning the despairs the spread of the data in the entire data set, the smaller, the closer the standard deviation to 0, the closest the data towards the mean. The third one is the measure of shape, and the measure of shape will tell you about the symmetry of the data. Which, when you try to design a bell curve, when a bell curve is drawn, how the data is spread, you will say it is symmetric once both sides from the before and after the mean mirror itself. So for example, you will have to fold the data from the mean. When you try to fold the data from the mean, it looks perfectly exactly the same, and that's symmetry. And skewness is something that is telling you about how the data is oriented either towards the left or the right. Is it most of the data or the values are oriented towards before the mean or after the mean? And you have kurtosis. Kurtosis talks about the peakness of the data, whether how peak is the data. And there are 3 types of kurtosis. We have mesocortic, leptocortic, and platycortic. Sometimes when the data is so spread, it looks like so flat, and we call this one platycortic. When it's too steep, we call this one leptocortic. It is so just normal distribution, we call this one mesocortic. And then you have modality. And then the next one is association and regression, association and prediction. So when we try to relate data from one another, when you try to relate the relationship, and sometimes the relationship is expressed through a probability of -1 to a +1. That's the range of relationship. A negative, perfect -1 to a perfect +1. And the association will tell you that they are directly correlated, or they have direct relationship. When data A goes up, data B also goes up, and that gives you a positive relationship. The closest to one, the direct the relationship. And if it is closest to 0, there is no relationship. But if it is close to -1, or if it's perfectly -1, meaning there is a reverse relationship. When variable A goes up, variable B goes down, it goes in a different way. And then the next one is prediction regression. So could a variable A predicts variable B? When A goes up, does it really predicts that B also goes up? And again, this could be measured through a probability of -1 to 1. And this is either bivariate or a two variable relationship. When you do regression, either this could be a two variable, we call that one two variate, bivariate, or a multivariate, one variable to 2 to 3 or more variables. So those are things under descriptive statistics. And these things could be known as, when you have a research, this will fall into qualitative research. And the next one is the interval ratio. So inferential statistics. Inferential statistics, very easy. When there will be estimation, this could be expressed this could be measured with a particular point or an interval among values in the data set. So what does estimation mean? Estimation is, we try to look into the sample, whether this number in a particular sample or this sample could really represent the entire population. And once we are dealing with this estimation, once we are trying to express or we're trying to show what the population is with a particular sample, that becomes an inferential stat, and that could fall to a quantitative research. And the last is hypothesis testing. And there are two famous. By the way, there are different types of hypothesis, but there are two which are famous. And we call this one null hypothesis and alternative hypothesis. Null hypothesis are expressed through H and 0, and an alternative hypothesis is expressed through H, it's 1 or it's A, or for null hypothesis it could be it's O or it's 0, and that is how it is expressed. And then the null hypothesis is a negative statement, and sometimes it could be rejected or it could be accepted. So example for this is, for example, a variable A is not has no significant relationship with B, and if it is rejected, meaning to say that there could be a relationship between A and B. And this could be measured through different two forms, either parametric and non-parametric. Parametric statistics are falls on interval and ratio type of data, and the non-parametric falls into ordinal type of data. Just remember on this when we try to differentiate, because there are differences between these two, the parametric and non-parametric, depending on the assumptions. But the simplest way that I can give you is parametric statistics are those statistics that falls on interval and ratio data, and non-parametric are those that are ordinal type of data. And all of this, when you do estimation and hypothesis testing, this falls on quantitative research. Remember this. The kind of statistics will tell you what kind of research you are doing, and what kind of research that you are doing will tell you what kind of statistics that you are doing. So it seems vice versa. So there is, again, they are like husband and wife. You cannot separate them. They are married. They go together. So the kind of research, when you say qualitative research, then you will be dealing with descriptive stats. When you go quantitative research, then you go inferential statistics. But whether qualitative or quantitative, whether mixed method or multi-method, we still deal with statistics. We cannot escape statistics. Thank you for listening. And next time I'll be discussing about the measures of central tendency. And I hope you will follow, subscribe, and give your comments on my presentation. Thank you and have a good day.